Oceans. They cover 2/3 of the surface of the Earth. For centuries, humans have been able to do little more than skim across the ceiling of this alien world. Most of it remained tantalizingly out of reach. The creatures of the deep were shrouded in mystery, surrounded by myths of lost cities, mermaids, and monsters. Over the last 150 years, we have explored ever deeper into the ocean. Since then, our knowledge of this hidden world has been steadily rising. But we began on the surface, staring at an endless horizon. So what is an ocean? An ocean is quite simply a large expanse of water. Today, there are 5 of them. The Arctic Ocean is the smallest and made up almost entirely of ice. The Southern Ocean completely surrounds the continent of Antarctica. Next is the Indian Ocean, with the warmest sea on Earth. The Atlantic is so big, it would cover the continents of Africa and Europe and still have room to spare. But even this is dwarfed by the largest ocean of all, the Pacific. It covers 1/3 of the globe. Parts of it are 35,000 feet deep. That's 29 Empire State Buildings piled up. In ancient times, people had little idea about the huge scale of the oceans. The Greeks believed a river ran around the edge of the world, surrounding a single landmass. They called the river Ocean. From earliest times, people thought the Earth was flat, and that if they traveled too far, they would be dragged over the edge by a huge waterfall. The Earth was never flat, but its surface has changed much over billions of years. Soon after it was formed, the Earth began to cool, clouds formed, and rain gradually filled the oceans. Much later, land formed into a single continent called Pangaea, surrounded by one vast ocean called Panthalassa, meaning all sea. Ever since, the rocks of the Earth's crust have been shifting to produce the continents as we know them today, and the oceans have formed between them. Under the waves, the Earth is still restless. Deep beneath the Atlantic, hidden under 2 miles of water, molten rock bubbles out of the ground. It has formed a mountain range longer than the Himalayas, the Rockies, and the Andes combined. Called the Mid-Atlantic Ridge, it is a sign of growth. The Atlantic is actually getting wider each year. It may be a slow process, but it all adds up. If Christopher Columbus made his voyage today, he'd find the ocean stretched further by a whole ship's length. Where there is growth, there must also be shrinkage, or the Earth would burst open. The shrinkage happens at the deepest points on Earth, or trenches. Here, one part of the crust slides under another, carrying the rock down into the heart of the planet. Around Hawaii, the ocean is so deep that if you add its depth to the height of the peak above, Mauna Kea, you discover the highest mountain on Earth. But despite millions of years of change, the oceans remain linked in one vast mass. Wherever you are on the planet, dip your toe in the water and you are connected to every ocean. Considering the scale of the ocean, it's a wonder that this planet is not called water instead of Earth. Oceans are where life began and the source of the water that sustains all life. They contain 99% of the living space on the planet, a living space providing homes for the most remarkable creatures. There's a huge variety of life in the ocean, many more groups of animals than on land. The startling colors of coral may resemble flower gardens, but these submarine cities are made up of billions upon billions of tiny creatures. Although they are small, coral have created the largest structure on the planet made by living things, Australia's Great Barrier Reef. The largest fish is the whale shark, reaching 60 feet long, but this huge creature eats mostly tiny plankton. And some smaller fish join forces to create an impression of size. These shoals contain tens of thousands of fish, all swimming together to confuse predators. There's a complex food pyramid in the ocean. At the base are plankton, countless tiny plants and animals. These are in turn eaten by thousands of fish, which may provide a meal for a single whale, the largest creatures on Earth. The color of the ocean always seems blue, because other colors penetrate water less easily. Red light travels the least distance. And even blue light can only reach down 1,500 feet. Below this, the waters are dark, and until recently we believed devoid of life. How wrong we were. Like light, we were excluded from the depths, and for centuries the oceans were a barrier to exploration, even on the surface. Legend has it that the Egyptians and Phoenicians found it impossible to defeat the currents of the Mediterranean until the invention of the sail, nearly 8,000 years ago. In ancient times, the power of the oceans was attributed to gods, like the Greek Poseidon, who rode in a carriage drawn by dolphins. Sea creatures were said to dance at his passing. In early voyages around 1000 AD, the Vikings may have been the first to discover America, but such journeys were rare. The great civilizations of the world remained isolated. For early civilizations, maps were virtually useless, although by the time of Ptolemy, the Greeks had changed their thinking. Instead of a central landmass, his map shows the ocean completely surrounded by land. By 1519, the map of the world began to resemble the picture we have now. In that year, Magellan set off on his 3-year voyage, the first circumnavigation of the globe, which proved at last that all the oceans were joined. Early explorations were fueled by trade. Huge profits could be made by transporting exotic goods and spices, with ships able to carry far more than any land transport. Even today, 95% of world trade still travels by sea. But as voyages extended around the world, beneath the surface, the oceans and their inhabitants remain mysterious. Sailors turned sea creatures into monsters, with tall tales of huge beasts with names like the Kraken and Hydra. Our understanding of ocean chemistry was also rather shallow. For centuries, people believed a thin layer of salt water rested on top of a mass of fresh water. In the 1660s, scientists finally analyzed samples from the deep ocean and concluded that all the water in the ocean is salty. There is so much salt that if you could extract all of it from the ocean, it would cover every bit of land to a depth of 5 feet. We'd all be up to our necks. Saltiness varies throughout the oceans, and the more salt, the more buoyant the water. As people on the Dead Sea, the saltiest sea on Earth, can attest. By the 1670s, an Italian scientist showed in a simple test that saltiness is one factor in keeping the oceans on the move. Using a divided tank with salty water-colored blue and lighter, fresher water left clear, he showed that the denser salty water will seep under lighter fresh water, pushing it up and creating circular flows, currents. Many animals hitch rides on ocean currents. One of the oldest creatures on Earth, the blue shark, uses the Gulf Stream on its North Atlantic journey in search of food. They travel thousands of miles with their young around the ocean, returning in time to breed. Currents present a problem to plants and creatures that want to stay still. The roots of kelp are actually an anchor to hold the plant in place, withstanding currents that are the equivalent of an underwater gale. Holding on with their tails are delicate seahorses. They are among the slowest of all fish and cannot swim against the current, so the tail becomes an anchor. At his desk in Washington in the 1840s, Matthew Fontaine Maury also liked to stay put. Known as the pathfinder of the seas, he studied thousands of ships' logs, worked out their speed in different conditions, and created the first ever comprehensive charts of wind and current. Their impact was immediate. Sailing times across the oceans were slashed by up to 1/3. Novel methods have been employed to track the shifting seas. In the 1800s, thousands of bottles were released into the Atlantic. Each one had a note asking the finder to return to sender, making it possible to chart the currents. The original message in a bottle. A clue to the direction of the currents exists in the drain of every wash basin in the world. North of the equator, the water disappears in a clockwise direction. Travel through an imaginary pipe to the southern hemisphere, and you'll find the same spiral appears to move counterclockwise. The same is true of the ocean currents because it's the spin of the Earth that determines the water's movement. Water takes 3,000 times more energy to heat than air, and it takes longer to grow cold. So water stays warm even as it flows to the poles, smoothing out temperature differences like a global thermostat. Where hot and cold air meet, terrible storms may develop, unleashing the mighty force of the ocean. The highest wave ever recorded was 1.5 times the height of Niagara Falls. In the 19th century, we discovered that it's the wave that moves, not the water. An object floating in open sea will move in a circle back to its original position as a wave passes. It's a different matter, of course, at the shore, that area repeatedly covered and uncovered by the tides. As levels of land and sea have shifted over thousands of years, even greater areas have been uncovered, leaving fossils of sea creatures high and dry. And cities flooded, like Atlantis, the legendary city forever hidden in the water. Levels of the ocean vary with the Earth's changing temperature. The slightest temperature rise, just half a degree, would expand the ocean and melt enough ice to cause flooding around the world. Currently, more than a tenth of the water on the planet is locked up in the ice caps, forbidding places for humans, but many animals have adapted to the cold. The Weddell seal is the most southerly mammal, thriving in the Antarctic freezer. In the winter, it spends most of its time submerged because the water below the ice stays warmer than the air above. The oceans abound with life, and humans have always harvested their riches. For centuries, fishermen relied on luck as much as skill in finding the best catch. Eventually, they learnt the habits of ocean creatures. Dolphin often swim above tuna, so humans tagged along to find their catch. But for years, they would accidentally kill the dolphin as well as the tuna. Modern fishing methods have become far more sophisticated in targeting their catch. They are now so effective that in some areas they threaten to fish the oceans clean. The first confirmation of life throughout the deep came in the 1870s, when the ship HMS Challenger, equipped with the latest technology, made the first full-scale study of the ocean. Temperatures at different depths were measured, and nearly 4,500 new species of plants and animals were collected. The voyage proved conclusively that there was abundant life in the ocean depths. To find their position at sea, early sailors relied on measuring latitude from the stars, using a sextant, and longitude from the sun's altitude at certain times of the day. But knowing the time at sea was an inexact science. In the 18th century, clocks used pendulums, and the motion of a ship made these very unreliable. It was only with the invention of the chronometer that the problem of longitude was conquered. The pendulum was replaced by an escapement wheel, and as a byproduct, the world gained a more accurate watch. Early efforts to measure depth relied on a cannonball and rope, hardly accurate when the line itself was heavy enough to keep playing out even after the shot hit bottom. A real case of how long is a piece of string. Today, depth is measured by sonar, like the echolocation used by dolphins. The oceans can be very noisy. The shrimp clicks with such frequency that it creates its very own sonar static. Sound travels 5 times further in water than in air, very effective for keeping in touch. The humpback whale's mating call is believed to be the acoustic equivalent of the peacock's tail, announcing the presence of a male to the females. Thanks to the distance sound travels, the males can start singing while they're still hundreds of miles away from the females. Although the song they sing keeps changing, all humpbacks of the same pod sing a similar song. Maybe they're just following the latest musical trends. No one, however, seems able to fathom the mysteries of the Bermuda Triangle. In this corner of the Atlantic Ocean, strange things happen to instruments. Whales lose their sense of direction, and there have been over 140 cases in which boats and aircraft have just vanished. There are just as many theories about where they have all gone. Some suggest they've traveled in time. Centuries ago, people believed that some animals would literally disappear for a while each year. A phenomenon we know today is migration. Turtles are among the greatest voyagers. Leatherbacks follow the currents and their food, jellyfish, thousands of miles from the West Indies, past Europe, and up to the Arctic. Humans have used the oceans to migrate too. Among the earliest were the Polynesians, who crisscrossed the Pacific, visiting every island, big or small, except, it seems, Australia. More recently, hundreds of thousands of Europeans crossed the Atlantic to America. This route gave rise to a famous ocean race, the Blue Ribbon, awarded for the fastest crossing. In the 1830s, the Great Western took 15 days, but by 1986, this had been trimmed to just 3.5 days. Nautical speed has always been measured in knots, because sailors would count the knots in a rope as it passed through their hands into the water from a ship, as the sand in a timer ran out. For humans to explore the deep ocean, they needed a protective shell. One of the first was Halley's diving bell, dating back to 1690. A wooden cask with an open bottom, it allowed scientists to descend in their own air bubble and study life to a depth of just 60 feet. In the 1830s, Augustus Zieber's hard-helmeted divers, looking more like astronauts than sailors, could go down to 200 feet, limited by the umbilical link to a ship above. Exploration in the 19th century prompted authors to dust off tales of underwater adventure, beasts, and monsters. Jules Verne and H.G. Wells set a fashion that filmmakers would be eager to follow, doing their best to recreate the drama of the deep. In 1943, it was Jacques Cousteau's invention of the scuba, standing for self-contained underwater breathing apparatus, that finally allowed us to fathom this new world untethered. But the first scuba dives only got us to a depth of 160 feet. A seal is able to dive straight off land and down into the depths. But humans can't. We must spend time adjusting to the pressure, and below certain depths, that pressure is just too much. How much? At the deepest point of the ocean, the pressure is the equivalent of a human trying to support 50 jumbo jets. Which makes the discovery of animals at these depths even more amazing. These creatures have adapted to the pressure with lightweight bones and muscles, and their skin is so fine that they literally disintegrate if we bring them to the surface. In the 1930s, two Americans, Beebe and Barton, set a new record for deep-sea diving, protected from the pressure in a bathysphere, named for the Greek words for deep ball. They reached 3,000 feet. We could finally observe life in the darkness of the depths. The deeper we went, the more we discovered. Cut off from any glimmer of sunlight, down here most creatures are able to make their own light, perhaps to dazzle predators or act as camouflage. Combined with lights from an exploring vessel, It makes some of them, like these comb jellies, look more like spacecraft than animals. And strangely enough, we knew the distance to the moon years before we knew the depth of the ocean. It took a scientist from landlocked Switzerland to invent a craft capable of reaching the deepest point on Earth, the depth of over 35,000 feet. In 1960, Auguste Piccard's vessel, the Trieste, reached the bottom of the Marianas Trench in the Pacific. It's like going down more than 3,000 floors in an elevator. And here in 1977, in the depths of our planet, lurked a surprise, a challenge to our understanding of biology. Life evolving without light. Somehow bacteria were living on hydrogen sulfide gas emitted by deep sea vents, and that bacteria became food for other creatures. Photosynthesis had a rival, chemosynthesis. We may have finally reached the deepest point on Earth, but only 1/20th of the ocean floor has been mapped. There may be millions of new species in the regions that remain hidden. But such findings will have to await some future journey. We are only visitors to this world, and in returning to our world, we can be sure of only one thing. Our knowledge of the deep is still little more than a drop in the ocean.